This video contains the solutions to sample exam number 2. So first we have some multiple choice questions, and this first one is asking about some identities. And so we want to know which of the following expressions is equivalent to secant of theta. Well, the relationship between secant and cosine, and all of the choices here have to do with cosine. So the relationship here is that secant of theta is the reciprocal of cosine. It's 1 over cosine theta. And we see that that's one of our choices, so C is the correct answer here. Now for number 2, we want to find the exact value of the cotan squared of pi over 3 and the tan squared of pi over 4. So we should know that since pi over 3 and pi over 4 are two of our nice, well-known angles in terms of our special triangles, it might help to convert pi over 3 to 60 degrees and pi over 4 to 45 degrees. And again, the conversion here is that if I want to go from radians to degrees, what I do is I multiply by 180 divided by pi. So when I do that with pi over 3, I get 60 degrees. When I do that with pi over 4, I get 45 degrees. It's a good idea, though, to get used to some of these nice angles that we see over and over again. So pi over 2, pi over 3, pi over 4, pi over 6, those should be ones that you become familiar with as you work more with these trigonometric functions. So for the 60-degree angle, the special triangle that we're thinking of looks like this. Here's my 60-degree angle. Up here is a 30-degree angle. I've got 1/2 down here, square root of 3 over 2, and then 1. So if I want the cotangent of pi over 3, what I should know is that cotangent is adjacent over opposite, and so the cotan of pi over 3 is 1/2 over square root of 3 over 2, which works out to be 1 over the square root of 3. And so if I square that, what I get is 1/3. So the cotan squared of pi over 3 is 1/3. The tan squared of pi over 4, well, pi over 4, the special triangle we're looking at, looks like this. Here's 45 degrees, here's 45 degrees, 1, 1, and the square root of 2. The tangent of 45 degrees is 1, and so if I square that, 1 squared is 1. So this problem is really asking me for 1/3 plus 1, which works out to be 4/3. So the answer here is D. For number 3 here, we want the reference angle for 250 degrees. So even though 250 degrees is not one of our nice angles, we can still think about the reference angle here. And the way that I would break this down is to think to yourself, well, a full circle is 360 degrees. 250 is less than 360, so this is less than one full circle. So if I go a quarter of the way around my circle, that's 90 degrees. Another quarter of the way around my circle is another 90 degrees, which gives me 180. If I went another quarter of a circle, that would get me to 270, and that's too far. So I only want to go to 250, which means I want to go 2 quarter rotations and then a little bit further. So this is 90, this is 90. And then 180 from 250 is 70. So the leftover here would be 70 degrees. And from what we know about reference angles, this reference angle here is 70 degrees. So the answer we're looking for is A. Remember, the reference angle is the angle formed between the terminal side and the x-axis, the acute angle. All right, moving on to number 4, which of the following is equivalent to cosine of theta? And again, what we're looking at, we see in the choices, we see pi over 2 minus theta, we see theta minus pi over 2. That should get us thinking about complementary angles. And what we know about complementary angles is that the cosine of theta is equal to the sine of the complementary angle, 90 degrees minus theta, which in radians would be written as pi over 2 minus theta. And since that's one of our choices, choice B here is our correct answer. All right, moving on. Talking about some general questions about the trig functions here. What's the domain of y equals sine of theta? Well, what we learned is that some of the trig functions, especially the ones where we're dividing by another trig function, tan is sine divided by cosine, cosecant is 1 divided by sine. When the bottom of that fraction is 0, then that gives us a value that's not in our domain. But sine of theta, we can take the sine of any angle we want. And so the answer here is that the domain of the sine function is all real numbers. For number 6, we're looking for which one of these is not a Pythagorean identity. And here this is just a little bit of memorization. So what you should know is that sine squared plus cosine squared equals 1. That's a Pythagorean identity, so the answer is not A. 1 plus cotan squared equals cosecant squared is another one. We get that from sine squared plus cosine squared equals 1 by dividing both sides by sine squared. So that's not the answer. Tan squared plus 1 equals secant squared. That's again another Pythagorean identity. We get that from our original sine squared plus cosine squared equals 1 by dividing both sides by cosine squared. And when we look at tan squared plus cotan squared equals 1, that doesn't match up with any of our Pythagorean identities, so that's the one that is not an identity. Now, finally, number 7 here, we want to convert degrees to radians. So earlier I told you how to convert from radians to degrees. If we want to go from degrees to radians, we multiply by pi over 180. So when we take 440 and multiply by pi over 180, we can reduce this fraction. We get 440 pi divided by 180. We can divide top and bottom by 10. We can divide top and bottom by 2. That gives us 22 over 9. And so our answer is 22 pi divided by 9. So choice B. All right, moving on. So now we've got some kind of fill-in-the-blank type of questions here, where we're just evaluating certain trig functions. So for the sine of 30 degrees, again, by this point, either you know the nice triangle, which we drew earlier, but I'll redraw again here. 60 degrees, 30 degrees, 1/2, square root of 3 over 2, and 1. And so then you remember that sine is opposite over hypotenuse by remembering SOHCAHTOA. And then the sine of the 30 degrees would be 1/2 divided by 1, which is just 1/2. Or that might just be a value that you have memorized. Cosine of 0, again, a couple of different ways to think about this. One is to draw the angle 0 in standard position. That would have initial side and terminal side on the positive x-axis. Pick your favorite point on the terminal side. Maybe I'll pick the point 1, 0. And then the r value would be 1. Cosine is a over r, which is 1 over 1, which in this case is 1. Or again, you might just have that value memorized. Tangent of pi over 2, again, we could draw that angle in standard position, or we can just remember that odd multiples of pi over 2 are not in the domain of tangent, because if we did sine over cosine, we would get sine of pi over 2 divided by cosine of pi over 2. But the cosine of pi over 2 is 0, and so that means that this is undefined. Sine of 210 degrees, we might do that by finding a reference angle. Similar to how we drew the angle earlier, 210 is in quadrant 3. The reference angle is 30 degrees. And so the sine of 210 is negative the sine of 30 degrees, negative because it's in quadrant 3, and the sine of 30 degrees is 1/2, so this is negative 1/2. Finally, cosecant of pi over 4, again, we might do this with reference angles. Negative pi over 4 is a clockwise rotation of 45 degrees. So my reference angle here is 45 degrees. Now cosecant is 1 over sine, so this is 1 over the sine of negative pi over 4. Since we're in quadrant 4, the sine of pi over 4 is negative, so this is 1 over the negative sine of pi over 4, which is 1 over minus 1 over the square root of 2, which is just negative the square root of 2. This time we have a triangle, so again, we're just remembering SOHCAHTOA. But we also need to figure out the length of this mysterious side over here. So maybe we'll call that A, and we'll know that a squared plus 3 squared equals 7 squared. So a squared plus 9 equals 49. So a squared equals 40. So a equals the square root of 40. So the sine of theta is opposite over hypotenuse, so that's 3 over 7. The cosine of theta is adjacent over hypotenuse, so that's the square root of 40 over 7. Tan of theta is opposite over adjacent, so 3 over the square root of 40. Cotan is the reciprocal of tangent, so flip that fraction over, square root of 40 over 3. Secant is the reciprocal of cosine, so that gives us 7 over the square root of 40. And then finally, cosecant is the reciprocal of sine, so that's 7 over 3. Moving on to number 10. Suppose that phi is an angle in quadrant 2 with sine of phi equals 2/3. Find the values of the remaining trigonometric functions of phi. So we've got this angle in quadrant 2. So we don't know exactly how big it is. We'll just draw sort of a random angle in quadrant 2. So there's our angle phi. And what we know is that the sine of phi is 2/3. So we can figure out the remaining values of the trig functions using identities. We'll start with the Pythagorean identity. We note that the sine squared of phi plus the cosine squared of phi equals 1. The sine of phi is 2/3, so that's 2/3 squared plus cosine squared equals 1. 2/3 squared is 4/9. Subtract 4/9 from both sides, we get 5/9. Take the square root of both sides, we get the square root of 5/9, which we can clean up a little bit and write that as the square root of 5 over the square root of 9, and the square root of 9 is 3. So the cosine of phi is radical 5 over 3. But hold on a second. Remember, we're in quadrant 2. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. When we took the square root of both sides, we need to not forget that we get a plus or a minus. So is it plus or is it minus? Well, in quadrant 2, the x values are negative. And since the cosine of that angle phi, if we were to think of a point on this terminal side, the x value of that point is negative. So if we think of this as a comma b, and this distance from the origin as r, the cosine is a over r. The a is negative, r is always positive, and so the cosine must be negative. So it's not square root of 5 over 3, it's negative the square root of 5 over 3. Now the other values of our trig functions can be constructed now that we know sine and cosine. Tangent is sine over cosine, so 2/3 divided by negative square root of 5 over 3, that's going to be 2 over negative square root of 5, or negative 2 over the square root of 5. Cotangent is the reciprocal of that, so radical 5 over 2. Secant is the reciprocal of cosine, so negative 3 over the square root of 5. And cosecant is the reciprocal of sine, so that'll be 3/2. All right, moving on, we have some application problems. So for this first one, the arm and blade of a windshield wiper have a total length of 34 inches. The blade is 25 inches long, and the wiper sweeps out an angle of 120 degrees. So the idea here is that we've got this windshield wiper, but only part of it is actually wiping the window. So the entire length here is 34 inches, but the blade itself is just 25. And then the blade sweeps out an angle of 120 degrees, so it's going to look a little something like this. So this angle here is 120 degrees, and so the area that's actually swept out by the wiper blade is actually, looks something like that. Okay, so what we see here is that we have actually two sectors of two different circles. A big circle with radius 34, and a small circle with radius 9. And I'm getting 9 by subtracting 34 minus 25. So the area that I'm looking for is the area of the sector of the big circle minus the area of the sector of the little circle, because the handle that holds the blade, that part's not sweeping out any actual area being cleaned. So the big sector has area 1/2 r squared theta. Remember, that's our formula for the area of a sector. In this case, the radius is 34, but the angle, well, we can't use 120 degrees, because remember, this formula only works when the angle is expressed in radians. So we need to take that 120, multiply by pi over 180, that works out to be 2 pi over 3. Now, using our calculators, 34 squared is 1156, multiplied by 2 pi over 3. The 1/2 cancels out this 2, and so what we end up with is 1156 pi divided by 3. Now the small sector, similar for area formula, 1/2 r squared theta. The small sector has radius 9. The theta is still 2 pi over 3. So this is going to be, again, this 2 is going to cancel out this 2. 9 squared is 81, so we get 81 pi over 3. And so when we subtract, we get 1156 pi over 3 minus 81 pi over 3. And so we get 1075 pi over 3. And the area here would be in square inches. Next up, we've got a paddle wheel with radius 4 feet that's being lowered into a flowing river. The current causes the wheel to rotate at a speed of 10 revolutions per minute, and we want to know the speed of the current. So if we think about this, our paddle wheel is being rotated at an angular speed of 10 revolutions per minute. So remember our formulas that we have here. We have that the angular speed, omega, is the angle that gets rotated divided by time. So that could be represented by revolutions per minute, but also degrees per minute or radians per minute. Our linear speed, which we represent with v, is the distance divided by the time. And then the relationship between s and theta is that s is the radius times the theta. So essentially, we're being given omega, and we're being asked for v, because we're being told that this wheel is spinning at a rate of 10 revolutions per minute, and the actual speed of the current is just going to be the speed at which a point around the edge of the wheel spins around. So the angular speed is 10 revolutions per minute. That's omega. But that's theta divided by t. And so what we want is v, which is s over t, but s is r times theta. So r is 4 feet. And theta over t is 10 revolutions per minute. But in order to do this conversion, we've got to convert revolutions to radians. Because remember, the formulas that we have in terms of the arc length on a circle, we have to measure our angles in radians. So the revolutions, one revolution is 2 pi radians. One full circle is 2 pi radians. And so 10 revolutions is going to be 10 times 2 pi, so 20 pi radians. So this is going to be 4 feet times 20 pi radians per minute. And so my speed of my current is 80 pi, 4 times 20, feet per minute. Next up, we've got a submarine that's at the surface that begins to dive at an angle of 15 degrees. We know that the submarine travels at a speed of 20 miles per hour. We want to know the depth of the submarine after 5 hours. So drawing our diagram here, we've got the surface of the water. This is the starting point of the submarine. And then the submarine dives at an angle, and the angle is 15 degrees. Now, 20 miles per hour for 5 hours means that the submarine is going to travel a distance of 100 miles. And so what we want to know is, at that point, what is this depth d? So we've got a right triangle, and the two distances that we either know or are interested in are the opposite and hypotenuse sides compared to this 15-degree angle. So the trig function that is easiest to use that relates the opposite and the hypotenuse is the sine. So the sine of 15 degrees is the opposite, which is d, divided by the hypotenuse, which is 100. So that means that d is 100 times the sine of 15 degrees. That's the exact answer that we're looking for. Now the approximate answer we would get by typing sine of 15 degrees into our calculator, which is going to give us 0.258819. Multiply that by 100, that's going to give us 25.8819. We're asked to round to 2 decimal places, so that's going to be 25.88 miles. All right, last one. We've got this person, Gina, who's up in a hot air balloon. She wants to know how high up she is. She measures the angle of depression to a landmark that's to the east of the balloon to be 54 degrees. A few minutes later, she travels 100 feet east. She checks again and finds the altitude of depression to be 61 degrees. So she's up here in this balloon. She looks down at the ground. And the angle of depression is the angle between the horizontal and that ground. So in this case, that's 54 degrees. But when she moves 100 feet to the east, she checks again. So now she's at this point. She checks again. And now the angle has gotten a little bit bigger, which we can kind of see from the picture. So now it's 61 degrees. And she wants to know the altitude. So let's call A the altitude. Now, the other distance that we don't know is the distance from her position to that landmark. So maybe I'll call that distance D. So we actually have two variables in this problem. A is the one we really want to figure out, but D is also something that we're going to need to be thinking about. And we've got two triangles. So our two triangles, one has a 54-degree angle, has opposite side A and adjacent side 100 plus D. The other triangle has a 61-degree angle, has opposite side A and adjacent side D. So we're going to use tangent here because we're talking about opposites and adjacents. So the tangent of 54 degrees is opposite over adjacent, so in this case A over 100 plus D. And the tangent of 61 degrees is opposite over adjacent, A over D. So that second equation is easier to deal with because it doesn't have the 100. So let's start there. So we've got D times the tan of 61 equals A. Remember, A is what we want. So knowing that A equals D times the tan of 61 is great if we knew what D was. But the other equation also gives us a solution for A. It tells us that 100 plus D times the tan of 54 equals A. So since both of these equal A, we can set them equal to each other. So we get 100 plus D times the tan of 54 equals D times the tan of 61. And we can solve that for D. So let's multiply this out. We get 100 times the tan of 54 plus D times the tan of 54 equals D times the tan of 61. Let's get the things with the D's in them on one side of our equation. So we get 100 times the tan of 54 equals D tan 61 minus D tan 54. We can factor out a D. And then divide both sides by the tan of 61 minus the tan of 54. So we get that D equals 100 tan 54 divided by the tan of 61 minus the tan of 54. So what's A then? A is what we really want, right? D, I guess that's nice that we figured that out, but A is really the thing that we want. So let's use the easier equation. Let's use this equation here to figure out what A is. So A is going to be this whole thing, D, so I'm just going to copy that and paste it, times the tan of 61. So 100 tan 54 divided by tan of 61 minus the tan of 54. So all of that nasty mess is our exact answer. And then when we type that in our calculators very carefully using lots of parentheses, we get that A is approximately 580.61 feet.